Hey everyone, so today we're going to briefly discuss this paper here entitled Reduce Achilles Tendon Stiffness, Disrupts Calf Muscle Neuromechanics in Elderly Gait. Okay, and this paper really gives us a nice insight into the importance of a responsive and stiff Achilles tendon in elderly individuals. Okay, which is a very important concept within the context of improving movement control in this population. Because when we think about something like fall prevention strategies, I'm sure a lot of our minds will be taken back to basic balance training on unstable surfaces. But I think very few of us consider the importance of a responsive and stiff Achilles tendon to help us quickly manage external perturbations acting on our anatomy in this population as well. And that can really help guide a different rehabilitation strategy. Okay? So when discussing neuromechanics, what does calf muscle neuromechanics actually mean? And when we're discussing neuromechanics, we're essentially highlighting how a change in the mechanical behavior, which is what we actually observe as practitioners, how does that change in mechanical behavior influence the nervous system? Or from another perspective, what does the mechanical behavior of the body tell us about how the nervous system is actually interacting or communicating with the body? Does it trust the body's ability to manage forces? Does it lead to the expression of appropriate muscle tone to manage forces? Or is it leading to increased protective tone in certain tissues to manage forces? Okay, so let's talk through some of the key features of the study. So firstly, it draws our attention to the unique architectural differences between distal tissues and proximal tissues. So proximally, we have muscles with longer muscle fiber lengths but with shorter tendons, and then distally we have muscles with shorter fiber lengths but longer tendons. Okay, and the key to economical movement or the robust management of external forces, external perturbations acting on our anatomy from distal to proximal, as shown in the study, is a tuned interaction between the plantar flexors and the Achilles tendon. And what that means is that we need to express an appropriate amount of muscle activity in the plantar flexors to allow the tendon to lengthen and shorten and store and release energy. Okay? But when the tendon becomes less stiff and less responsive, more compliant, what happens is the plantar flexors have to express more muscle activity, much more muscle activity to manage those forces. Okay, which has an impact on how well we can manage forces acting from distal to proximal. This can also lead to a strong perception of continued tightness and tension in the plantar flexors, for example. But generally, we're looking at this from the standpoint of how well we're buffering those forces, how well we're managing those forces from distal to proximal. So when the Achilles tendon becomes more compliant, the plantar flexors have to express much more muscle activity to manage those forces. And the second key feature here for us is the redistribution of workload from distal to proximal when we lose those capacities distally to better manage forces. Okay, so instead of the ankle, the foot, all the associated tissues, dampening those forces, buffering those forces from distal to proximal, and allowing us to quickly respond to those perturbations, what happens is this redistribution of workload into the proximal tissues. Okay, around the hip, around the low back. And this is a really key insight for us at IKN, because in order to express a robust interaction with the real world, with the uncertainty of the real world and the unpredictable forces acting on our anatomy on an ongoing basis, we want to manage forces distally as best we can until forces become so great that we need to shift that workload into the proximal tissues. But when we're shifting the workload into the proximal tissues too quickly, then that can lead to a change in the metabolic and the energetic demand with movement. And a key thing to consider here, like we spoke about in the last portion, was that when the workload shifts proximally, we have to recognize the architectural differences here, because when we have muscles with longer muscle fiber lengths and shorter tendons proximally, those tissues aren't really equipped to quickly manage those external perturbations, to quickly manage those forces like the distal tissues. So within this population, it does seem that they often lose that capacity to express a stiff and responsive Achilles tendon, which then changes the behavior of the plantar flexors. And this then has an impact not only on how we walk, but how we manage external perturbations acting on our anatomy during movement, which is a key feature for any fall prevention plan. Okay, and this then leads to an increase in the energetic demands of movement and a redistribution of the workload from distal to proximal. So what does this mean? This means that we need to dedicate, as practitioners, we need to dedicate interventions towards restoring this Achilles tendon responsiveness in this population, because it's just as important in this population as it is in a younger and a more athletic population.